Picture this. You're standing on Earth looking up at the night sky, and you see Mars glowing like a tiny red dot in the darkness. It's our neighbour, sitting there just 40 million miles away on a good day. That sounds far, but in cosmic terms it's practically next door. We've sent robots there, we've mapped every crater, and we're planning to send humans within the next decade or two. Mars feels achievable, doesn't it? Like we're on the verge of becoming an interplanetary species. But here's the thing that will absolutely blow your mind. That same night sky you're looking at contains Alpha Centauri. The closest star system to our own is just 4 light years away. 4! That's nothing compared to the vastness of our galaxy, which stretches 100,000 light years across. Alpha Centauri is literally our next-door neighbour in the cosmic neighbourhood. And yet, despite being so close, that single journey to our nearest stellar neighbour would take us over 70,000 years with our current technology. 70,000 years. That's longer than all of recorded human history. So why is it that we can dream of walking on Mars, but we can't even begin to imagine escaping our solar system? What invisible prison are we trapped in, and why does the universe seem determined to keep us locked inside this tiny corner of space? I'm about to take you on a journey that will completely change how you think about space travel, our place in the universe, and the mind-bending physics that govern everything around us. We're going to explore the brutal mathematical realities that make interstellar travel seem impossible, the exotic technologies that might offer us hope, and the profound implications of being potentially trapped in our cosmic backyard forever. But first, let me tell you exactly what we're dealing with here, because the scale of this problem is so vast that most people can't even wrap their heads around it. And once you understand the true scope of what we're up against, you'll realize that this isn't just about rockets and fuel. This is about the fundamental nature of reality itself. The solar system that we call home is enormous by human standards. If Earth were the size of a marble, the solar system would stretch across an area larger than a football field. Neptune, our outermost planet, orbits at an average distance of about 2.8 billion miles from the Sun. The Voyager probes, launched in 1977, are just now reaching the edge of our solar system after travelling for over 4 decades. That's how big our cosmic neighbourhood really is. But here's where it gets absolutely insane. The distance from our Sun to the nearest star is about 7,000 times larger than the distance from our Sun to Neptune. 7,000 times. If our solar system were the size of a coin, the nearest star would be sitting on another coin roughly 4 miles away. And that's just the closest one. The galaxy contains hundreds of billions of stars, most of them so far away that their light takes thousands or even millions of years to reach us. Now you might be thinking, okay, so space is big. We get it. But humans are clever. We've figured out how to fly, we've been to the moon, we've sent probes to every planet in our solar system. Surely we can figure out how to go faster and reach the stars eventually, right? Well, that's where physics comes in to completely ruin the party. Because it turns out that the universe has some very strict rules about how fast things can travel, and those rules make interstellar travel a nightmare of epic proportions. Let's start with the most obvious approach. Just build a bigger rocket. The way we get to space now is by burning massive amounts of fuel to accelerate our spacecraft to incredible speeds. To reach the International Space Station, we need to accelerate to about 17,000 miles per hour. To escape Earth's gravity entirely, we need to hit 25,000 miles per hour. To get to Mars in a reasonable amount of time, we need to go even faster. So for interstellar travel, we just need to go much, much faster, right? Well, let's do the math. To reach Alpha Centauri in a human lifetime, say 50 years, we'd need to travel at about 25 million miles per hour. That's roughly 1,000 times faster than we've ever sent anything before. And here's the kicker. Achieving those speeds with conventional rockets would require more fuel than exists in the entire observable universe. I'm not exaggerating. The rocket equation developed by Russian scientist Konstantin Tsiolkovsky over a century ago shows us that the amount of fuel needed for a journey increases exponentially with the desired speed. Double your speed and you need roughly 4 times as much fuel. Triple your speed and you need 9 times as much fuel. By the time you want to go fast enough for interstellar travel, the fuel requirements become absolutely astronomical. Let's put this in perspective. The Saturn V rocket that took us to the moon weighed about 3,000 tons when fully fueled, but only about 50 tons of that was actual spacecraft. The rest was fuel. For an interstellar journey at the speeds we're talking about, you'd need a fuel tank the size of a small planet just to accelerate a tiny probe to the necessary velocity. But wait. It gets worse. Even if we could somehow solve the fuel problem, we'd run into another fundamental barrier: the speed of light. Einstein's theory of relativity tells us that nothing with mass can travel faster than light, which moves at about 186,000 miles per second. This isn't just a technical limitation we might overcome someday. It's a fundamental law of the universe, like gravity or the conservation of energy. As objects approach the speed of light, strange things start to happen. Time begins to slow down relative to the outside world. Distances contract. And most importantly, for our purposes, the energy required to accelerate an object increases dramatically. To accelerate even a single proton to 99%, the speed of light requires enormous amounts of energy. To accelerate a spacecraft carrying humans to those speeds would require more energy than our sun produces in millions of years. So, conventional rockets are out. Chemical propulsion, nuclear propulsion, even exotic forms of propulsion we haven't invented yet, all run into the same fundamental problems. The distances are too vast, the energy requirements too extreme, and the speed of light too limiting. But humans are nothing if not creative when faced with impossible challenges. Over the decades, scientists and engineers have proposed dozens of theoretical solutions to the interstellar travel problem. Some are based on known physics but require technologies we don't have yet. Others push the boundaries of what we think is possible, and a few venture into the realm of pure speculation, requiring us to discover entirely new laws of physics. One of the most promising approaches involves something called fusion propulsion. Instead of burning chemical fuel like current rockets, these engines would fuse hydrogen atoms together, releasing enormous amounts of energy in the process. Fusion reactions power the sun and other stars, so we know they can produce incredible amounts of energy from relatively small amounts of fuel. A fusion rocket could theoretically accelerate a spacecraft to perhaps 10 or 15% the speed of light, making interstellar journeys possible within human lifetimes. But here's the catch. We still don't know how to build a fusion reactor that produces more energy than it consumes. Despite decades of research and billions of dollars in funding, controlled fusion remains just out of reach. We can make fusion happen in laboratories for brief moments, but sustaining it long enough to power a spacecraft is still a dream. Then there's the concept of antimatter propulsion. When matter and antimatter come into contact, they annihilate each other completely, converting their entire mass into pure energy according to Einstein's famous equation E equals mc squared. This is the most efficient energy conversion process known to physics, making antimatter the ultimate rocket fuel. The problem is that antimatter is incredibly difficult to produce and store. Creating just a few atoms of antimatter requires massive particle accelerators and enormous amounts of energy. To fuel an interstellar spacecraft, we need to produce antimatter on an industrial scale, which is currently impossible with our technology. Even if we could produce enough antimatter, storing it safely would be another monumental challenge, since it would annihilate instantly upon contact with any normal matter. Some scientists have proposed even more exotic solutions. Solar sails use the pressure of sunlight to accelerate spacecraft without requiring any fuel at all. By deploying enormous, ultra-thin reflective sails, a spacecraft could gradually accelerate to impressive speeds over time. The concept has been tested on small scales and actually works, but scaling it up for interstellar travel would require sails hundreds of miles across and decades of acceleration time. A more advanced version of this concept involves using powerful lasers instead of sunlight. By beaming intense laser light at a spacecraft's sail, we could accelerate it to much higher speeds than solar pressure alone could achieve. This approach might allow us to send tiny probes to nearby stars within a few decades, though carrying human passengers would still be impossible. But all of these solutions, impressive as they might be, still leave us trapped by the fundamental limitations of physics. Even if we could build perfect fusion rockets or produce unlimited antimatter, we'd still be limited by the speed of light. Even if we could travel at 99% light speed, reaching the far side of our galaxy would take over 100,000 years. The universe is simply too big for conventional travel, no matter how advanced our technology becomes. This is where some scientists start to think outside the box entirely. What if we don't need to travel through space at all? What if we could somehow bend space itself, creating shortcuts through the fabric of the universe? Einstein's general relativity tells us that massive objects actually warp the geometry of space and time around them. This isn't just a metaphor. Space itself is curved by the presence of matter and energy. In theory, if we could manipulate space-time directly, we might be able to create wormholes, stable tunnels connecting distant parts of the universe. Step through one end and you'd instantly emerge light years away. The mathematics of general relativity does allow for such structures to exist, but actually creating them would require forms of matter and energy that may not exist in our universe. We'd need something called exotic matter, which has negative energy density to keep a wormhole stable. No one has ever observed exotic matter, and many physicists doubt it can exist at all. Another speculative concept involves something called an Alcubierre drive, named after physicist Miguel Alcubierre, who first described it in 1994. This theoretical engine wouldn't move a spacecraft through space at all. Instead, it would contract space in front of the ship while expanding space behind it, creating a bubble of warped space-time that carries the vessel along. From the ship's perspective, it would never exceed the speed of light, but it could effectively travel faster than light by riding the wave of contracting and expanding space. The Alcubierre drive is mathematically consistent with general relativity, but it faces the same problem as wormholes. It requires exotic matter with negative energy density to function. Even if such matter exists, the amount needed would be enormous, possibly requiring the mass-energy equivalent of entire planets. These theoretical solutions sound impressive on paper, but they highlight just how desperate our situation really is. We're essentially hoping that we can discover entirely new forms of matter that may not even exist, or figure out how to manipulate the fundamental structure of space and time itself. It's like being trapped in a prison and hoping the walls are made of a material that doesn't actually exist. But let's step back for a moment and consider what we're really dealing with here. The problem isn't just about distance or speed or fuel, it's about time itself. Human civilization, as we know it, has only existed for about 10,000 years. The oldest continuous governments on Earth are maybe a few hundred years old. The longest-lived human institutions rarely last more than a millennium. And yet, even with perfect technology, a journey to another star would take longer than most human institutions have ever survived. Think about that for a second. If we launched a generation ship to Alpha Centauri today using the best possible propulsion system we could theoretically build, the people who arrived would be separated from us by dozens of generations. They would have evolved their own culture, their own language, their own entire way of life during the journey. The civilization that finally reaches another star might be as different from us as we are from ancient Mesopotamians. This brings us to one of the most sobering aspects of interstellar travel, the generation ship problem. If we can't travel fast enough to reach other stars within a human lifetime, then any interstellar journey becomes a one-way ticket, not just for the travelers, but for our entire species. The people who leave Earth would essentially be starting a new branch of humanity, one that might never have any contact with their homeworld again. Imagine trying to organise such a mission. You need to convince thousands of people to spend their entire lives aboard a spacecraft, knowing they'd never see their destination. You'd need to create a closed ecosystem that could sustain human life for centuries without any resupply from Earth. You'd need to solve problems we've never even thought of, like how to maintain genetic diversity in a small population over hundreds of generations, or how to preserve knowledge and culture across centuries of isolation. The psychological challenges would be enormous. What happens when people born on the ship start to question the mission? What if they decide they don't want to continue toward a destination they'll never see? What if they want to turn around and come home? The history of human exploration is filled with mutinies, rebellions, and failed expeditions, and those were for journeys lasting months or years, not centuries. Even if we could solve all these problems, we'd still face the fundamental question of whether such a journey would be worth it. The energy and resources required to build and launch an interstellar generation ship would be staggering. We're talking about the economic output of entire nations, devoted to a project that wouldn't bear fruit for hundreds of years. In a world where we struggle to fund projects that take decades to complete, asking humanity to invest in something with a centuries-long payoff seems almost impossibly optimistic. But here's where the story takes an even darker turn. Even if we could somehow overcome all these obstacles, even if we could build fusion rockets or antimatter engines or exotic space warping drives, we'd still be trapped by something much more fundamental: the expansion of the universe itself. You see, the universe isn't just big, it's getting bigger. Space itself is expanding, carrying distant galaxies away from us at ever-increasing speeds. The farther away a galaxy is, the faster it's receding from us. At some point, galaxies become so distant that they're moving away from us faster than the speed of light. Not because they're travelling through space at light speed, but because the space between us and them is expanding faster than light can cross it. This means there's a boundary around us, called the cosmic horizon, beyond which we can never travel no matter how advanced our technology becomes. Even if we could somehow build a spacecraft that travels at the speed of light, there are parts of the universe we could never reach because they're moving away from us faster than we could ever catch up. Right now, this cosmic horizon is about 46 billion light-years away, which seems like plenty of room to explore. But the universe is accelerating its expansion, driven by something called dark energy that we don't understand. As time goes on, this boundary will actually start to shrink. Distant galaxies will cross the cosmic horizon and disappear from our view forever. Eventually, even nearby galaxies will be carried away by the expansion of space, leaving us truly alone in an island of darkness. The Andromeda Galaxy, our nearest major neighbour, is actually moving toward us and will collide with our Milky Way in about 4 billion years. But after that collision, the merged galaxy will be surrounded by an ever-expanding void as all other galaxies disappear beyond the cosmic horizon. Future civilizations, if they exist, will look out at a universe that appears to contain only their own galaxy, with no evidence that other galaxies ever existed. This cosmic perspective makes our solar system seem less like a prison and more like a life raft in an infinite ocean. We're not just trapped by the limitations of physics and technology. We're trapped by the fundamental structure of the universe itself, floating in a small bubble of space that's slowly being separated from everything else by forces we can barely comprehend. But perhaps the most unsettling aspect of our cosmic imprisonment is how it affects our understanding of our place in the universe. For centuries, humans have imagined that we might someday spread across the stars, colonizing distant worlds and building a galactic civilization. Science fiction has painted pictures of vast interstellar empires with starships travelling between worlds as easily as we cross oceans. These dreams have shaped our entire conception of humanity's future. We imagine that our descendants will explore strange new worlds, that they'll encounter alien civilizations, that they'll build something greater than anything we can imagine here on Earth. The idea that we might be forever confined to this single solar system challenges some of our most fundamental assumptions about progress and human potential. It also raises profound questions about the nature of life in the universe. If interstellar travel is this difficult for us, with our advanced technology and scientific understanding, what does that say about other potential civilizations? Are they all trapped in their own solar systems, forever separated from each other by the vast emptiness of space? This could explain one of the biggest mysteries in science, the Fermi paradox. Named after physicist Enrico Fermi, this paradox asks why we haven't encountered any evidence of alien civilizations, despite the vast number of stars and planets in our galaxy. If life is common in the universe, and if civilizations naturally develop space travel, then we should see evidence of their presence everywhere. The night sky should be filled with the signatures of alien technology. The fact that we see none of this could mean that intelligent life is incredibly rare. Or it could mean that every civilization, no matter how advanced, eventually runs up against the same fundamental barriers that trap us. Maybe the universe is filled with intelligent species, all of them confined to their own solar systems, all of them looking out at the stars and wondering if they're alone. This possibility transforms our understanding of cosmic loneliness. We might not be alone because life is rare. We might be alone because the universe itself keeps all life forms isolated from each other, trapped in their own cosmic bubbles by the tyranny of distance and the immutable laws of physics. The implications of this cosmic quarantine extend far beyond just space travel. If we're truly trapped in our solar system, then everything humanity will ever accomplish must happen within this tiny corner of space. Every discovery, every achievement, every moment of beauty and wonder in human history will unfold within the gravitational embrace of our sun. This realization forces us to confront some uncomfortable truths about our cosmic situation. If we're genuinely stuck here, then every resource we'll ever have access to, every piece of matter and energy that will fuel human civilization, already exists within our solar system. We're not just prisoners of distance and physics, we're prisoners of scarcity, locked in a cosmic vault with a finite inventory that must sustain us for the rest of human existence. Think about the implications of that for a moment. Every atom of carbon, every molecule of water, every gram of rare earth elements that will ever power human technology is already here, floating in this gravitational bubble we call home. There's no cosmic resupply mission coming. There's no intergalactic trade route that will deliver fresh resources when we run out. What we have is what we get forever. Now, you might be thinking that our solar system contains plenty of resources to keep us going for millions of years. And you'd be right, technically. The asteroid belt alone contains enough metal to build structures larger than entire planets. The outer planets are rich in hydrogen and helium that could fuel fusion reactors for eons. The moons of Jupiter and Saturn harbour more water than all of Earth's oceans combined. But here's the thing that makes this situation so psychologically challenging. We're not just talking about surviving in our solar system. We're talking about thriving, growing, and continuing to push the boundaries of human achievement while knowing that we can never leave this cosmic neighbourhood. It's like being told you can live in the most beautiful mansion ever built with enough rooms to explore for a lifetime, but you can never step outside the front door. This constraint fundamentally changes how we have to think about humanity's future. Instead of dreaming about spreading across the galaxy, we need to focus on becoming masters of our own solar system. Instead of planning interstellar colonies, we need to figure out how to build sustainable civilizations on Mars, Europa, Titan, and the countless other worlds that orbit our sun. The good news is that our solar system is actually an incredibly diverse and resource-rich environment. Mars offers the possibility of a second Earth, with seasons, polar ice caps, and an atmosphere that could potentially be terraformed. Venus, despite its hellish surface conditions, has regions of its upper atmosphere where the temperature and pressure are surprisingly Earth-like. We could potentially build floating cities in the clouds of Venus, harvesting the planet's abundant carbon dioxide for industrial processes. The moons of the outer planets present even more exotic possibilities. Europa harbours a subsurface ocean that contains more water than all of Earth's seas. Titan has lakes of liquid methane and an atmosphere so thick you could fly through it with nothing more than wings strapped to your back. Enceladus shoots geysers of water ice into space, creating a natural source of both water and energy. But even these exciting possibilities come with a sobering reminder of our limitations. No matter how successfully we colonize Mars or build cities on Europa, we'll still be operating within the same basic constraints. We'll still be using the same finite pool of resources, still bound by the same physical laws, still trapped within the same cosmic boundary. This brings us to one of the most profound questions raised by our cosmic imprisonment. What does it mean to be human in a universe where we can never leave home? How do we maintain our sense of purpose and wonder when we know that every star we see in the night sky is forever beyond our reach? Some people find this prospect deeply depressing. They see it as a fundamental limitation on human potential, a cosmic ceiling that will forever constrain our species' growth and development. If we can't explore the galaxy, if we can't encounter alien civilizations, if we can't build the vast interstellar empires of science fiction, then what's the point of all our technological advancement? But others see it differently. They argue that our cosmic isolation might actually be a gift, forcing us to focus on what really matters, building sustainable societies, protecting our environment, and creating meaningful lives for ourselves and future generations. Instead of always looking toward the next frontier, we'd be compelled to make the most of the world we have. There's something almost poetic about this perspective. For thousands of years, humans have been explorers, always pushing toward new horizons. We've crossed oceans, climbed mountains, and ventured into space, driven by an insatiable curiosity about what lies beyond the next hill. But what if the ultimate frontier isn't out there among the stars? But what if it's right here in learning to live sustainably and harmoniously within the cosmic home we've been given? This shift in perspective could fundamentally change how we approach technology and scientific research. Instead of focusing on faster rockets and more powerful engines, we might invest more heavily in closed-loop life support systems, sustainable energy production, and the kind of technologies that would allow human civilization to flourish for millions of years within our solar system. We might also find ourselves developing new forms of exploration that don't require physical travel. Virtual reality technologies could allow us to experience distant worlds in incredible detail, even if we can never visit them in person. Advanced telescopes and robotic probes could serve as our eyes and ears throughout the galaxy, sending back data that would let us study alien worlds and search for signs of life without ever leaving our solar system. But even as we adapt to our cosmic constraints, we shouldn't abandon hope entirely. The history of human achievement is filled with supposedly impossible challenges that were eventually overcome through ingenuity, persistence, and sheer determination. The idea of powered flight was considered impossible until the Wright brothers proved otherwise. The notion of splitting the atom was pure fantasy until scientists figured out how to harness nuclear energy. It's entirely possible that our current understanding of physics is incomplete, that there are phenomena and possibilities we haven't discovered yet. Maybe there are forms of energy we haven't detected, or ways of manipulating space and time that we haven't imagined. The universe has surprised us before, and it might surprise us again. Consider the concept of quantum entanglement, where two particles can be instantly connected across vast distances, seemingly violating the speed of light limitation. While we can't use entanglement to send information faster than light, it suggests that the universe operates according to principles we're only beginning to understand. Who knows what other quantum phenomena might exist that could revolutionize our understanding of space and time? There's also the possibility that we're thinking about interstellar travel in entirely the wrong way. Maybe the solution isn't to send human bodies across space, but to send human minds. If we could somehow upload human consciousness into digital form, we could transmit that information to distant stars at the speed of light. A digital copy of a human could arrive at Alpha Centauri in just 4 years, where it could be downloaded into a robotic body or even a cloned human form. This approach would sidestep many of the physical limitations that make conventional space travel so difficult. Digital information has no mass, so it's not limited by fuel requirements or acceleration constraints. It can travel at light speed, making even distant stars reachable within reasonable timeframes. And it doesn't require life support systems or radiation shielding, eliminating many of the technical challenges that plague traditional spacecraft. Of course, this solution raises its own philosophical questions. Would a digital copy of a human consciousness really be the same person, or would it be something else entirely? What would happen to the original human after their mind was uploaded? These questions touch on fundamental issues of identity and consciousness that we're nowhere near resolving. But perhaps the most important thing to remember is that our cosmic imprisonment, if it's real, doesn't diminish the value of human existence or achievement. The fact that we're confined to our solar system doesn't make our lives less meaningful or our accomplishments less significant. Every work of art, every scientific discovery, every act of love and kindness that has ever occurred in human history happened within this same cosmic boundary. The universe may be vast and mostly empty, but it has produced something extraordinary in this small corner of space. Conscious beings capable of contemplating their own existence, of creating beauty, of caring for each other across the generations. That's not a consolation prize for being trapped in our solar system. That's the whole point. Maybe the question isn't whether we can escape our cosmic prison. Maybe the question is whether we can learn to see our solar system not as a prison, but as a home, a place where an entire species can grow, learn, create, and thrive for millions of years to come. A place where we can build something beautiful and lasting, even if it's confined to this tiny bubble of space we call our own. The stars may be forever beyond our reach, but they're not beyond our wonder. Every time we look up at the night sky, we're participating in a cosmic conversation that spans the entire universe. The light from distant stars carries information about worlds we'll never visit, but it also connects us to the fundamental processes that created the atoms in our bodies and the planets we call home. We are made of star stuff, as Carl Sagan once said. We carry the universe within us, even if we can never fully explore it. And maybe that's enough. Maybe being conscious participants in the cosmic story, even from our small corner of space, is the most extraordinary thing of all. But this raises another question that cuts to the heart of our cosmic predicament. If we're truly alone in our solar system, if every other civilization in the universe is similarly trapped, then what does that say about the nature of intelligence itself? Are we all just cosmic accidents, brief flickers of consciousness in an otherwise empty universe? Or are we something more significant, something that gives meaning to the vast emptiness around us? The answer to that question might determine not just how we feel about our cosmic imprisonment, but how we choose to live within it. Because whether we're trapped or free, whether we're alone or surrounded by distant neighbors, we're still here. We're still conscious. We're still capable of wonder, love, discovery, and creation. And that, perhaps, is the most important thing of all. The isolation we face isn't just physical, it's temporal. Consider this mind-bending reality. Even if we could somehow break free from our solar system tomorrow, even if we discovered some revolutionary technology that let us travel at incredible speeds, we'd still be racing against time itself in ways most people never consider. You see, stars don't live forever. Our sun, the gravitational anchor that holds our entire cosmic neighborhood together, has a lifespan. It's been burning for about 4.5 billion years, and it has roughly another 5 billion years left before it begins to die. That sounds like plenty of time, but remember, we're talking about the ultimate deadline for everything humanity will ever accomplish. In 5 billion years, our sun will start to expand into a red giant, first swallowing Mercury and Venus, then potentially Earth itself. The comfortable zone where liquid water can exist will shift outward, maybe to the moons of Jupiter or Saturn. Any human civilization that still exists will have to migrate to these outer worlds or face extinction. But here's what makes this timeline even more constraining. We're not just racing against our own star's death. We're racing against the death of all stars. The universe is approximately 13.8 billion years old, and stellar formation peaked billions of years ago. We're already living in what astronomers call the stelliferous era, the age when stars dominate the universe's energy output. But this era won't last forever. In the far future, maybe 1 trillion years from now, star formation will cease entirely. The universe will enter what cosmologists call the degenerate era, where the only sources of energy will be the slow decay of white dwarf stars and the occasional collision of brown dwarfs. After that comes the black hole era, where even these remnants will have disappeared, leaving only black holes slowly evaporating through Hawking radiation. This cosmic timeline puts our imprisonment in an entirely different context. We're not just trapped in our solar system during some golden age of universal abundance. We're trapped during the only time in cosmic history when complex life is even possible. The universe had to be just the right age, with just the right mix of elements, with stars burning at just the right rate, for something like us to exist at all. And that raises a terrifying possibility. What if the window for interstellar travel isn't just closed for us, but for everyone? What if every civilization in the universe faces the same fundamental constraints, the same impossible distances, the same energy limitations? What if the universe is designed in such a way that intelligence can emerge, but it can never truly connect across the vast emptiness of space? This would explain why the universe seems so quiet, why we haven't detected any signs of vast galactic civilizations or interstellar commerce. It's not that alien life doesn't exist, it's that alien life, like us, is trapped in isolated pockets throughout the galaxy, each species confined to its own solar system, each looking out at the stars and wondering if anyone else is out there. The mathematics of this isolation are staggering. Our galaxy contains somewhere between 100 billion and 400 billion stars. If even a tiny fraction of those stars host planets with intelligent life, there could be millions of civilizations scattered throughout the Milky Way. But if each of them is trapped in their own solar system, they might as well be in separate universes for all the contact they'll ever have. Think about the implications of that for a moment. There could be alien Shakespeare writing poetry around a star in the Andromeda galaxy. There could be alien Einstein discovering the secrets of relativity near the galactic center. There could be alien children playing games and laughing under the light of a distant sun. But none of them will ever know that we exist, and will never know about them. This cosmic loneliness isn't just a philosophical problem, it has practical implications for how we think about our future as a species. If we're truly alone, if we're the only intelligence we'll ever encounter, then every decision we make about our planet, our society, and our technology becomes infinitely more important. We can't count on learning from alien civilizations that have solved the problems we're struggling with. We can't hope that some advanced species will share their technology with us or help us overcome our limitations. We can't even assume that if we destroy ourselves, intelligence will continue to exist elsewhere in the universe. For all we know, we could be the only conscious beings in our entire cosmic neighborhood. This responsibility is both terrifying and inspiring. Terrifying because it means that every mistake we make, every environmental disaster we cause, every war we fight, potentially puts the only known intelligence in this corner of the universe at risk. but inspiring because it means that every work of art we create, every scientific discovery we make, every act of compassion we show might be unique in the cosmos. The pressure of this cosmic responsibility might actually be good for us. When you know you're the only game in town, when you realize that your success or failure might determine whether intelligence continues to exist in your part of the universe, it tends to focus the mind wonderfully. We can't afford to waste time on petty conflicts or short-sighted thinking. We need to become worthy of our cosmic inheritance. But this brings us to another disturbing aspect of our imprisonment, the question of whether we're actually suited for long-term survival in space at all. Human bodies evolved over millions of years to function in Earth-specific environment. We need exactly the right atmospheric pressure, the right mix of gases, the right temperature range, the right amount of gravity. We're like tropical fish, exquisitely adapted to our particular aquarium but potentially unable to survive anywhere else. The health effects of long-term space travel are already becoming apparent from astronauts who spend months on the International Space Station. Their bones lose density, their muscles atrophy, their cardiovascular systems weaken, their eyes change shape, affecting their vision, their immune systems become compromised, and that's just from 6 months in low Earth orbit, still within the protective embrace of our planet's magnetic field. For true interstellar travel, we'd be talking about exposure to cosmic radiation levels that would be lethal over time. We'd be dealing with the psychological effects of total isolation from Earth, with no possibility of rescue or return. We'd be asking human beings to function in an environment that their bodies and minds were never designed to handle. This suggests that even if we could solve the technical problems of interstellar travel, we might discover that we're biologically unsuited for it. We might be like deep-sea creatures, perfectly adapted to our high-pressure environment, but unable to survive in the shallow waters of space. Our cosmic prison might not just be imposed by physics, but by biology itself. Of course, we could potentially overcome these biological limitations through genetic engineering or cybernetic enhancement. We could modify human bodies to be more radiation resistant or to function better in low-gravity environments. We could replace biological organs with artificial ones that don't deteriorate in space. We could even upload human consciousness into robotic bodies that are specifically designed for the harsh environment of interstellar space. But at what point would these modifications make us something other than human? If we have to change everything about ourselves to survive in space, are we still the same species that looked up at the stars and dreamed of reaching them? This is yet another way that our cosmic imprisonment might be absolute. Even if we could physically escape our solar system, we might have to stop being human to do it. The philosophical implications of this are staggering. It suggests that consciousness itself might be inherently local, tied to specific planetary environments and biological forms. The universe might be filled with intelligence, but each form of intelligence might be so specifically adapted to its homeworld that interstellar travel is not just technically impossible, but biologically meaningless. This would mean that the diversity of life in the universe is even greater than we imagined, but also that it's forever separated by unbridgeable gaps. Every planet that develops complex life would produce its own unique forms of consciousness, each perfectly suited to its particular environment, each completely unable to survive anywhere else. In this view, Earth isn't just our home planet. It's the only possible home for anything recognizably human. Mars colonists would eventually evolve into something different, adapted to the lower gravity and thinner atmosphere. Space habitats would produce their own unique forms of human consciousness, shaped by artificial environments and closed ecological systems. Over time, even our own solar system might become populated by dozens of different human subspecies, each adapted to its particular niche, each potentially unable to survive in the environments that produce the others. We wouldn't just be trapped in our solar system, we'd be trapped in an ever-fragmenting web of isolated human communities, each evolving in its own direction. This fragmentation might actually be inevitable, even if we never leave our solar system. As we spread throughout the asteroid belt, the moons of Jupiter and Saturn, and the outer reaches of our cosmic neighborhood, the different environments and challenges we face will shape us in different ways. Communication delays between distant outposts will create cultural isolation. Different resource availability will drive technological development in different directions. Within a few thousand years, the humans living on Europa might be as different from Earth humans as we are from our ancient ancestors. The people mining asteroids in the outer solar system might develop their own languages, their own cultures, their own ways of understanding the universe. Our solar system might become not a single human civilization, but a collection of related species, all descended from Earth life but adapted to radically different environments. This kind of speciation might be the natural fate of any intelligence that spreads beyond its home planet. Instead of vast, unified galactic civilizations, the universe might be filled with countless small, isolated groups of related species, each adapted to its particular corner of space, each unable to survive in the environments that produced the others. The irony is that this biological imprisonment might be even more absolute than the physical one. We might eventually develop technologies that could, in theory, carry us to the stars. But by the time we're advanced enough to build such technologies, we might be so changed by our adaptation to space that we no longer have any desire to use them. Imagine humans who have spent thousands of generations living in the low-gravity environment of the asteroid belt. Their bodies would be tall and fragile, their bones thin and light. They might communicate through radio waves rather than sound, since sound doesn't travel in vacuum. They might see in different wavelengths of light, adapted to the specific radiation environment of their habitats. Would such beings even recognize Earth as their ancestral home? Would they have any interest in visiting other star systems when they've spent millennia perfecting their adaptation to this one? They might look at our dreams of interstellar travel the way we look at a fish's desire to climb a tree. Theoretically possible with enough modification, but ultimately pointless. This brings us to what might be the most profound question raised by our cosmic imprisonment. What does it mean to be human in a universe where humanity itself is constantly changing? If we're trapped in our solar system, if we're forced to adapt to radically different environments, if we're destined to fragment into countless subspecies, then what exactly are we trying to preserve? The answer might be that we're not trying to preserve humanity as a biological form, but as a way of thinking, a way of understanding the universe, a way of creating meaning from the raw materials of existence. The specific shape of our bodies, the particular chemistry of our brains, the exact specifications of our DNA, these might all be temporary features of a deeper pattern that can survive even radical transformation. In this view, what makes us human isn't our biology, but our consciousness, our ability to ask questions about the universe and our place in it. As long as we maintain that capacity for wonder, that drive to understand and create and connect with each other, we remain human, regardless of what form our bodies take or what environment we live in. This perspective offers a kind of hope, even in the face of cosmic imprisonment. We might be trapped in our solar system. We might be forced to adapt to alien environments. We might fragment into countless subspecies. But the spark of consciousness that makes us human could survive and thrive in all of these forms. The universe might be vast and mostly empty, but it has produced something extraordinary in this small corner of space. The ability to think about itself, to question its own existence, to create beauty and meaning from the raw materials of matter and energy. That capacity isn't diminished by being confined to a single solar system. If anything, it might be enhanced by the challenge of making the most of our cosmic inheritance. But even as we adapt to our cosmic constraints, we shouldn't lose sight of the bigger picture. Our imprisonment in the solar system isn't just a technical problem to be solved or a biological limitation to be overcome. It's a fundamental aspect of the universe we live in, a reminder that consciousness itself might be a rare and precious phenomenon that emerges only under very specific conditions. The fact that we exist at all, that we can contemplate our own existence and wonder about our place in the cosmos, might be the most extraordinary thing in the universe. The stars may be forever beyond our reach, but they're not beyond our understanding. Every time we look up at the night sky, we're participating in a cosmic conversation that spans billions of years and countless light years. We are the universe thinking about itself. We are matter organized in such a way that it can contemplate its own existence. We are the cosmos awakening to its own beauty and complexity. And maybe that's not a consolation prize for being trapped in our solar system. Maybe that's the whole point. The weight of this cosmic perspective forces us to confront perhaps the most unsettling question of all. What if our imprisonment isn't just physical, but temporal? What if we're not just trapped in space, but trapped in time itself, living in a brief window of cosmic history that's rapidly closing? Consider the accelerating expansion of the universe I mentioned earlier. This isn't just an abstract cosmological phenomenon. It's actively shrinking the sphere of space that we could theoretically reach, even with perfect technology. Every second that passes, more galaxies cross the cosmic horizon and disappear from our accessible universe forever. We're like passengers on a sinking ship, watching the lifeboats drift away one by one. But the timeline gets even more constraining when you factor in the practical realities of technological development. Even if we could somehow build a spacecraft capable of traveling at a significant fraction of light speed, how long would it take us to develop such technology? Conservative estimates suggest that fusion propulsion, our most promising near-term option for fast interstellar travel, might be achievable within the next century or two. But remember, we'd need to go much faster than fusion alone could provide. Antimatter propulsion or exotic space warping technologies might take thousands of years to develop, if they're possible at all. And during those thousands of years, the universe continues expanding, carrying potential destinations farther and farther away. It's like trying to catch a taxi that's accelerating away from you. The longer you take to start running, the faster you need to run to catch up. Eventually, no matter how fast you can run, the taxi will be moving too quickly for you to ever reach it. We might be facing the cosmic equivalent of missing the last bus home. This temporal constraint adds another layer of urgency to our cosmic imprisonment. We're not just dealing with vast distances and impossible energy requirements. We're racing against the fundamental structure of space-time itself, trying to develop breakthrough technologies before the universe expands beyond our reach entirely. The psychological impact of this realization is profound. It means that every year we spend arguing about funding for space research. Every decade we waste on conflicts that could be resolved through cooperation. Every century we spend developing the wrong technologies brings us closer to permanent cosmic isolation. But perhaps even more disturbing is what this timeline suggests about other potential civilizations in the universe. If the window for interstellar travel is this narrow, if the technical requirements are this extreme, if the cosmic expansion is this relentless, then most intelligent species in the universe might miss their chance entirely. Think about it this way. A civilization needs to develop advanced spaceflight technology during the relatively brief period when their local galactic neighborhood is still accessible. They need to master fusion or antimatter propulsion or exotic physics before cosmic expansion carries their target destinations beyond reach. They need to do all of this before their home star dies, before their planet becomes uninhabitable, before their species goes extinct from any number of cosmic catastrophes. The odds of any civilization threading this needle successfully are incredibly small. Most species might develop intelligence too late in their star's lifetime, or too late in cosmic history, or simply too slowly to beat the expanding universe. They might achieve spaceflight just in time to discover that everywhere they wanted to go has already moved beyond their reach. This could explain the great silence that surrounds us. The universe might not be quiet because life is rare. It might be quiet because every civilization faces the same impossible deadline and most of them simply run out of time. If this is true, then we're not just imprisoned in our solar system. We're imprisoned in a cosmic moment, a brief window of opportunity that's already half closed. The stars we see in tonight's sky might represent our only chance to connect with something larger than ourselves, and that chance is slipping away with every passing second. But here's where our story takes a strange turn, because this temporal prison might actually be the key to understanding something profound about consciousness itself. What if the constraints that trap us in our solar system aren't limitations at all, but necessary conditions for intelligence to exist? Consider the delicate balance required for complex life to emerge. We need a star that's stable enough to provide consistent energy for billions of years, but not so massive that it burns out quickly. We need a planet at just the right distance to maintain liquid water, with just the right atmosphere to protect us from radiation. We need a large moon to stabilize our planet's rotation, and a giant planet like Jupiter to deflect dangerous asteroids. All of these conditions are incredibly specific and incredibly rare. The vast majority of star systems in the universe lack the precise combination of factors necessary for complex life. Most planets are too hot or too cold, too large or too small, orbiting stars that are too unstable or too short-lived. This suggests that consciousness might be inherently local, not because we're trapped by the limitations of physics, but because consciousness can only emerge under very specific, very rare conditions. The universe might be designed in such a way that intelligence naturally develops in isolated pockets, each perfectly suited to its particular environment, each unable to survive anywhere else. In this view, our cosmic imprisonment isn't a bug in the universe's design. It's a feature. We're not trapped despite being conscious. We're conscious because we're trapped. The isolation forces us to make the most of our local environment. It compels us to develop sustainable technologies, to solve problems through cooperation rather than conquest, to find meaning and purpose within the boundaries we're given. A species that could easily hop between star systems might never develop the depth of understanding, the technological sophistication, or the social cohesion necessary for long-term survival. This perspective transforms our solar system from a prison into a perfect laboratory for consciousness. Every challenge we face, from climate change to resource scarcity to social inequality, becomes an opportunity to develop the wisdom and capability that a truly advanced civilization needs. Maybe the species that do eventually escape their solar systems aren't the ones with the fastest rockets or the most exotic technologies. Maybe they're the ones that have learned to build sustainable, harmonious civilizations within their cosmic constraints. Maybe interstellar travel isn't a goal to achieve through technological force, but a privilege to be earned through wisdom and maturity. But this raises yet another troubling possibility. What if we're not just imprisoned by distance and time and biology, but by our own nature as conscious beings? What if consciousness itself creates barriers that make interstellar travel impossible, regardless of our technology? Think about the psychological challenges of a generation ship journey. You're asking people to spend their entire lives working toward a goal they'll never see, for the benefit of descendants they'll never meet. You're asking them to maintain social cohesion and technological capability over centuries of isolation and hardship. You're asking them to preserve knowledge and culture across dozens of generations without any external input or validation. These aren't just practical problems, they're fundamental challenges to the way conscious minds work. Humans are motivated by immediate rewards, personal relationships, and tangible progress toward achievable goals. We struggle to maintain focus on projects that take decades to complete, let alone centuries. The very consciousness that makes us want to explore the stars might also make us incapable of actually reaching them. We might be trapped, not by the laws of physics, but by the laws of psychology, doomed to dream of journeys we can never psychologically sustain. This paradox might be universal. Any species intelligent enough to contemplate interstellar travel might also be too intelligent to actually attempt it. The same mental flexibility that allows for abstract thinking and long-term planning might also generate enough doubt, fear, and alternative priorities to prevent truly long-term projects from ever being completed. Consider how difficult it is for human civilization to coordinate on projects that span even a few decades. Climate change, for example, requires sustained global cooperation over timescales that challenge our political and economic systems. Most governments struggle to maintain consistent policies across election cycles, let alone across centuries. If we can't coordinate effectively on problems with 50-year timescales, how could we possibly coordinate on interstellar journeys with 1,000-year timescales? The social and political challenges of such projects might be even more insurmountable than the technical ones. This suggests that consciousness might be inherently self-limiting. The more intelligent a species becomes, the more aware they become of the risks, costs, and uncertainties of interstellar travel. They develop better risk assessment capabilities, more sophisticated cost-benefit analysis, more nuanced understanding of the psychological and social challenges involved. Eventually, they might conclude that interstellar travel simply isn't worth the enormous risks and costs, especially when their home solar system offers so many opportunities for growth and exploration. They might choose to focus their efforts on building perfect societies within their cosmic boundaries rather than risking everything on uncertain journeys to distant stars. If this is true, then the universe might be filled with advanced civilizations that have consciously chosen cosmic isolation. They might have the technology to travel between stars, but they've decided that such journeys are too dangerous, too expensive, or simply too pointless to pursue. This would explain why we don't see evidence of vast interstellar civilizations. It's not that such civilizations can't exist. It's that any species wise enough to build them is also wise enough not to try. But perhaps the most profound implication of our cosmic imprisonment is what it suggests about the nature of meaning itself. If we're truly alone, if we're forever confined to this single solar system, if every conscious being in the universe faces the same isolation, then meaning can't come from external sources. We can't rely on alien wisdom to guide us, or galactic civilizations to inspire us, or cosmic purposes to direct us. Meaning, in a universe of cosmic prisons, has to be something we create ourselves. It has to emerge from our relationships with each other, our understanding of our local environment, our ability to find beauty and purpose in the specific circumstances we've been given. This isn't a limitation, it's a liberation. It means that the significance of human life doesn't depend on our ability to conquer the galaxy or discover alien civilizations. It depends on our ability to create something beautiful and meaningful within the boundaries we've been given. Every act of love, every work of art, every scientific discovery, every moment of wonder and connection that occurs within our solar system is complete in itself. It doesn't need to be part of some larger galactic story to have value. It doesn't need to be witnessed by alien observers to be meaningful. We are the meaning makers of our corner of the universe. We are the ones who transform raw matter and energy into consciousness, beauty, and purpose. We are the ones who look at a random collection of atoms and see a sunset, who hear vibrations in air and call it music, who experience patterns of neural activity and call it love. The universe might be vast and mostly empty, but it has produced something extraordinary in this small corner of space. The ability to create meaning from meaninglessness, to find purpose in purposelessness, to generate hope in the face of cosmic indifference. And maybe that's not just enough. Maybe that's everything. Maybe the point of consciousness isn't to escape our cosmic prison, but to transform it into a cosmic home, to take this tiny bubble of space we've been given and fill it with so much beauty, wisdom, and love that it becomes the most important place in the universe. Because in the end, that's what we've already done. Earth isn't just a random planet orbiting a random star in a random galaxy. It's the place where matter first learned to think about itself. It's the place where the universe first became conscious of its own existence. It's the place where atoms first organized themselves into patterns complex enough to contemplate infinity. That's not a consolation prize for being trapped in our solar system. That's the most extraordinary achievement in cosmic history. And it happened here, in this place, with these constraints within these boundaries. The stars may be forever beyond our reach, but they're not beyond our influence. Every time we choose love over fear, creation over destruction, cooperation over conflict, we're sending ripples of meaning through the fabric of space-time itself. We're proving that consciousness can flourish even in isolation, that intelligence can create beauty even within limitations, that life can find a way to matter even in an indifferent universe. Our cosmic prison might be absolute, but our capacity to transform that prison into something beautiful and meaningful is infinite. And maybe that's the real secret of consciousness. Not the ability to escape our limitations, but the ability to transcend them through the sheer force of will, imagination, and love. We are trapped in our solar system, yes, but we are also free to make that trap into the most wonderful place in the universe. And perhaps, in the end, that freedom is all we ever really needed. The question that remains then isn't whether we can escape our solar system. The question is what we'll do with the time we have within it. Will we spend our cosmic inheritance wisely, creating something beautiful and lasting? Or will we waste it on conflicts and competitions that pale in comparison to the vast challenges and opportunities that surround us? The choice is ours. The universe has given us this moment, this place, this chance to prove that consciousness can flourish even in isolation. What we make of that chance will determine not just the future of humanity, but the future of meaning itself in our corner of the cosmos. And that responsibility, that opportunity, that cosmic significance of our choices might be the most liberating prison sentence ever imposed.